Let's see. Now, can you hear that? Hello, hello? All right, good. Okay, so we are in business. All right, so we are going to be on page 103, I believe. I will tell you guys that are in class, we are going to do things a little bit different. You don't need your devices. I don't even want them up. So I want you out of your devices. I want you in your textbook. We will doing that from now on. I don't want you to use Cami for your notes. We are going to go back to doing it like we did before. You're going to put your pencil to the paper and you are going to take notes, just like you would if we weren't doing all this craziness, okay? I am going to be like watching you. I'm going to be making sure that you are taking notes. If you're not taking notes, I will call you out and say, you need to be writing, you need to be taking notes. The reason I'm doing that is because I am not going to require you guys to submit your notes if you are physically sitting in my class. So since you are sitting in my class, I don't need you to take 7 different pictures of your notes. I'm just seeing you take your notes. I know you've got your notes done. Okay, I'll be walking around. I see that you've got your notes done. So the only thing that I'm going to need from my in-class students is a picture of your homework, okay? So you will just submit your homework page, and that's all that you have to submit. So that will be easier. You only have to upload 1 picture instead of uploading 7 pictures or 4 pictures or whatever it is, okay? So hopefully that will make your life a little bit easier. Those of you that are watching this online, you still have to submit your notes and your homework since you are not in class. And that goes for you guys too. If you are absent and you are making up the work, then you also need to submit your notes and your homework. The only reason you don't have to submit notes is if you are physically sitting in my class and I see you visually taking notes. Does that make sense? Okay. That also being said, I am not going to compete with your cell phones. I know I will lose that battle every single time. There's no way that you can be on your phone and paying attention to me. So I want those put away, put up. When I am done with my lecture, you are more than welcome to pull that phone out and check your text messages and snaps and all of that stuff, but just not at the same time that I am teaching. Make sense? Okay. So just make sure you're doing your best to stay on task with that. Obviously, no headphones, none of those things. You need to be in class, paying attention for the next 25, 30 minutes that I teach. The end of the class where you're working on your homework, you can kind of do your own thing. Everybody okay with that? Any questions with that? Okay, cool. So we are starting Unit 2. If for whatever reason you didn't take your chapter test, there's a couple of people in this class that did not take theirs, several people virtual that did not take theirs. I have emailed everybody. You need to get with me ASAP. Like, I just emailed somebody that's not in this class, and they said that they're helping their parents move. That's a 0. Like, you don't get to not take your test because of X, Y, and Z. Like, you have to take your test. You have to do your schoolwork on the day that you're supposed to be doing your schoolwork. It just is what it is, okay? So make sure that you are doing what you're supposed to be doing. We will be taking our tests and quizzes in class from pretty much here on out. Fridays will be more of a practice day or a recorded lesson. Speaking of Fridays, this is not always, but this Friday is not a teaching day, okay? So there's no instruction going to be done on this Friday. I have to do professional development. It's a teacher work day, but the students don't have to do any work. So for my class, you don't have anything. I can't promise you that your other teachers won't give you anything, but it's not an instructional day of school, okay? I think that covers all of the stuff. Does anybody have any questions about just like random things that you've experienced throughout the day that you've got questions about? Okay, well then let's do it. All right, so we're going to be on page 103 in your book. And we are starting to talk about transformations. You have talked probably about transformations back in your like 7th and 8th grade math class. I don't know how in depth your teacher got, but I'm sure they talked to you about different transformations, especially like dilations. Most people have done dilations before, where you make something double its size or half its size. A lot of times you do that in middle school math classes. So this is kind of on the same page of that, but we're going to be doing writing it as a function. So that will probably be new to, I would guess, all of you. So here is what we are trying to accomplish today. First thing is we are going to perform transformations on and off a coordinate plane. Okay, so performing transformations. We are also going to identify characteristics of transformations that are rigid motions and characteristics of transformations that are non-rigid motions. Now, you may not know what those words mean, but I will give you that information in this lesson. Then it also says represent a transformation as a function using coordinates and show how the function is transformed by a function. Okay? So that last bullet, number 3, is definitely going to be new information for everyone. But none of this is really hard. I do like the way that Springboard works this lesson out. So we're going to go through it just like they have intended. So it says, Mr. Scott directs the Marching Cougars, the band at Chavez High School. He uses the coordinate plane to represent the football field. For the band's first show, he arranges the band in a rectangle that is 6 marchers wide and 9 marchers deep. So each of those dots represents a band member, and that is their formation. It says the band begins marching down the grid in this formation. Then the marchers move apart from each other vertically while keeping the same distance between marchers within the same row. The diagrams on the next page show the initial shape of the marchers and the 2 transformations they undergo. To describe and classify the transformations, compare the pre-image to the transformation of the image. All right, so we've got some vocabulary terms, so let's look over in that box that says math terms. A transformation is a change in position, size, or shape of the figure. The pre-image of the transformation is the original figure. The image is the figure after the transformation. Okay, so everybody's seen like before and after pictures, you know, like you go and follow all these makeup artists and you see their before and then you see their after, or weight loss. You see the before picture, you see the after picture. Okay, so we've all seen before and afters. The before is what we call the pre-image, okay? The after is what we call the image. So you've got your pre-image, then you have the actual image. The image comes after the transformation, okay? So when you look at the bottom of that page, you can see 3 rectangles, 3 shaded rectangles. So it gives you the transformation. It's showing you what the band is doing. So I want you to take a second and do 1 and 2. Read number 1 at the bottom of that page. Answer that. Flip the page. Answer number 2. All right, number 1, what did you say happened? 6 units down. Okay, slid 6 units down, moved 6 units down. Something about the shape going down. Did it change in shape or did it just move down? Just move down. Okay, so then number 2 says compare 1 and 2. So what happens between 1 and 2? Okay, You're right, but give me some more descriptions. How did it get bigger? Stretch which direction? Vertical. We are seeing a vertical stretch, and you could hear that in what they were saying that the band was doing. If you remember what the band is doing, it says the band, then the marchers move apart from each other vertically, keeping the same distance between marchers in the same row. Okay, so if I'm in the band, I've got people on both shoulders. Okay, we're marching together in the same row, and then these people are directly in front of me, and I've got people directly behind me. So when we go from here to here, my shoulder partners are not moving. The people in front of me step away, and the people behind me step away. So we're spreading out those rows. Okay, so that is a vertical stretch. Very good. Now, number 3. Number 3 says transformation 1 is an example of a rigid motion. Here's your definition. A rigid motion keeps the same distance between the points that are transformed. In this situation, the marchers of the band, the shape and the size of the pre-image and image are the same. Okay, so rigid motion is a transformation that preserves the size and shape. So it moves, but it does not change its shape or size. That is a rigid motion. Okay, 3A. How does transformation 1 affect the distance between any two marchers in the band? It does not. It does not. They are the same distance apart. Now you're writing. I'm not, because I see you writing. Okay, my people online, you are writing. Okay, so it's the distance between the two marchers is the same, remains the same. Now we've got 3B. Okay, 3B says, how does transformation 2 affect the distance between the marchers? Okay, so the space doubles. Okay, that's good. That's one way to say it. Anybody else have a different way? Good. They stretch themselves out vertically. Okay, cool. All right, and the book even goes further, which I think is great, because we did talk about them stretching themselves vertically, but what happened to them horizontally? Stayed the same. Okay, so really 2 things are happening here. Our horizontal distance is staying the same, staying constant, whereas our vertical distance is spreading apart. Okay, now the next question with that 3B says, is transformation 2 a rigid motion? Why not? That's right. It doesn't stay the same size. It doesn't preserve the same size. It is getting larger vertically, obviously. So that is a no. It is not a rigid motion. So if it's not a rigid motion, then what is it? It's either rigid or non-rigid. Okay, it's nothing, no fancy name to it. It's just rigid or non-rigid. Those are your only 2 options, so that one would be non-rigid. Okay, now number 4. Review transformation 1. Each point in the pre-image is mapped to the point in the image. When you map something, we're talking about the same location. So top right to top right, top left to top left, bottom left to bottom left. That's mapping to each other. Okay, so it says, for this reason, the transformation can be expressed as a function. Complete the table to show the positions of the 4 corners of the rectangle. Figure A is mapped onto figure B. So you're going to flip back and forth, and you're going to say, okay, this 110 is mapped to 14. So if we look at that real quick, 110, if I can get my pen, 110 is top left, 14 is top left. So those 2 things are mapped to each other. So you are going to see who's mapped here, who's mapped here, and so on. So identify those on your table. All right, y'all help me fill mine in quickly. Who was with 1, 2? Okay, who's with 6, 10? 6, 4? And who's with 6? Okay, cool. All right, so then it goes on to say for B, for any given point, how does the transformation change the x coordinate and the y coordinate? What happens with our x coordinate? Good, x coordinate is the same. What happens with the y coordinate? How? Down 6, decreases 6. And you can see that because 10 minus 6 is 4. 2 minus 6 is negative 4. 10 minus 6 is 4. 2 minus 6 is negative 4. So you're decreasing 6 in the y column. Now, this number, letter C, says you can use the notation 1, 10 goes to. The arrow means goes to. 1, 10 goes to 1, 4 to show how a point is transformed. So we're specifically talking about that 1 point. 1, 10 goes to 1, 4. So that just tells you about one dot. But if we want to talk about all of the dots, then we can write it in function notation. To do that, you take x, y. That's any point, any of the band members. It doesn't matter which one, any of those, x, y is going to go to, and then you describe what happens. What happened to your x's? Nothing. So you just write x. There's no change. If there's no change, you don't put plus anything, minus anything. You just leave it alone. What happens to my y's? So if it goes down 6, how do I show that? Well, then that would just make everybody negative 6. We want to do y minus 6. So whatever y was originally, we still need to know that. Whatever it is, though, we're going to take away 6. So when you see that, you can see the transformation. So you won't always get a graph. They're not always going to graph it out for you. Sometimes the only thing that you're going to get is just a function. So for example, if I gave you this original, this is the pre-image, is going to be, tell me what happens to that shape. This tells me we go right 2 because x is your horizontal. Okay, so we're going right 2. And then this minus 1 tells me we're going down because y is your vertical. Okay, so you don't need a graph to know that. You can just apply what you know about expressions. If we have an x, we're moving left or right. If we have a y, we're moving up or down. Okay? All right, so now let's take a look at the other one. Let's look at number 5. If you look at number 5, you have another table, but this time we are comparing B and C. So fill that in as quick as you can. B and C. So flip back and forth to do B and C. Same way. Top left with top left. Top right with top right. All right, let's do it quick. What goes with 1, -4? Okay, what goes next? And 6, -4? 6, 8? Okay, my bad. And then 6, okay, and that goes to, okay, great. Perfect. Thank you. All right, so now let's describe what happened to the x's. What happened to those x coordinates? Same. Again, that did not change. What happens to the y coordinates? Anybody else see it? Did y'all hear her, what she said? Okay, one's positive, one's negative. That's true. They double. If I multiply this by 2, what's 4 times 2? 8. What's -4 times 2? So you're seeing it keeps that negative, so that really we're not having to think about the negative. The only thing that's happening is we are doubling it. So we're multiplying by 2, which is why we see the shape go, it just got bigger. It just doubled itself. It multiplied, okay? So can we write a function to represent that as well? Yeah. Are we going to be using plus and minus? No, because plus and minus controls up or down, left or right. We're not doing that. We are expanding it vertically. So who's going to be changing? Y. X stays the same. What happens to our y? So it's going to be 2y. So if you see that multiplication, that's where you see the dilation. If you remember back to your 7th and 8th grade math class, when you talked about dilating something, you would say the image has been doubled. You multiplied everything by 2. The image has been tripled. You multiplied everything by 3. If the image is half of its size, you multiply by 1/2. Anytime we're multiplying, we are dilating a figure. Now, we're not dilating the whole figure because not everything changed with this one. The only thing that changed was the y. That's why we only stretched vertically, not horizontally as well. If I wanted to stretch both the vertical and the horizontal, how would I do that? Exactly. Multiply them both by 2. Okay? If you want them both to be affected, multiply them both. Okay? All right. So now you get to practice. Look at number 6. Okay? Number 6 has 2 things that you get to practice with. A is there and then B is there. I want you to work on both of those. If you need a table, make a table. If you don't need a table, don't make a table. But either way, do those problems. Do you tear out like you had all unit 1 tore out? Or you just don't bring your book to class? Okay, cool. Okay, y'all. Before y'all get too far, as I walked around, there's some of us that have the first one mixed up. So I am going to show you a table, okay? So with this table, this is going to be my X and Y. This is going to be my pre-image. And then this one is going to be X plus 3, comma, Y. So who is being changed? The X, not the Y. The Y is staying the same. So we need to identify each of the 4 corners. So this one's at 2, 2. Then we have 2, 5. Then we have 5, 2, and 5, 5. Did I remember that right? Are those the right points? I think so. Okay, now what I'm going to do from there is add 3 to each of the X's. So 2 plus 3 is 5. 2 plus 3 is 5. 5 plus 3 is 8. 5 plus 3 is 8. So I did all of the X's first just to get that out of the way. X is done. Y stays the same. So I'm just writing 2, 5, 2, 5. From there, then I'm just plotting my new ordered pairs. So I've got 5, 1, 2, 3, 4, 5, 2, 5, 5. Then I have 8, 2, and 8, 5. Easy, easy, easy if you take a second to do the table. Now, do you have to do a table? No, but there are a lot of us that mess that one up. If we look at this here, you can see the only thing that's happening is you're moving all of the pieces of that box right 3 units. So visually, if you can in your head say, I'm taking this dot and going 1, 2, 3 and put its matching dot, that's fine with me, okay? But you've got to be able to do that correctly so that you can end up with this image. Questions about that? If you messed up, do you see your mistake? Cool. All right. Now, same thing with B. Again, it can be very helpful for us to have a table, especially since we're changing both the X and the Y, okay? Now, we're multiplying by this, so what's that tell me we're doing? Okay, we're getting larger, we're dilating. So this is at 1, 2, and 1, 5, is that right? 1, 2, 1, 5, and then we're at 3, 2, and 3, 5. So that literally takes me like 30 seconds. So it's not like I'm asking you to like, you know, climb a tree or anything. Like it's just very, very basic, easy, easy. Then you're just going to take each of the X's and multiply by 2. 1 times 2 is, 1 times 2 is 2. I'm just going straight down. I'm doing all my X's. 3 times 2 is, and 3 times 2 is. I like to do it that way just so I'm in the right same mindset because it won't always be 2 in both places. So I like to just say, okay, I'm multiplying by 2, multiply all the way down, do all of the X's. Now I have my Y's. These Y's are going to be multiplied by 2 as well. So what's 2 times 2? 5 times 2, 2 times 2, 5 times 2. So now I have my complete ordered pairs and I can plot those points. 2, 4, 2, 10, 6, 3, 4, 5, 6, 4, and 6, 10. Ta-da! Questions? Do you notice how this one, your corner pieces are not in the same spot? So like with a dilation, a true dilation back when you learned them in the past, it was dilated from a certain point, okay? That's not what we're seeing right here, okay? So that's why you have to literally take each ordered pair and view each ordered pair to see what's going to happen to each one. Any questions about all of that? No. Okay, number 7 is kind of silly, but we're going to go ahead and address it quickly. They want you to put a 4 in the pre-image, which is those. And then it says, describe how the number should appear in each image. So how is this 4 going to appear in this image? Same or different? It'll be the same, okay? How is it going to appear in this image? How much larger? That's right. Okay, so A is going to be exactly the same, and B is going to be twice as large. You have to do that on your homework. All they're wanting you to do is they're wanting you to see what happens to your shape, okay? Our shape is getting double its size. It's doubling not only horizontally, it's doubling vertically. So it doubles both ways. Awesome. Where are we at? We're doing great. You guys are crushing this lesson. Who's having fun? Yes, everyone on Zoom. This whole class just went crazy. They're all having the best time. Okay, number 8 and 9 on check your understanding. Okay, so if you look at the check your understanding, you get another chance to practice that. This time, your X and Y are both affected with a plus and minus. So let's pause and talk about that. What's happening in this transformation? Without graphing it, without doing anything, tell me in your words what is happening here. Left 2. This one's going left 2, and this one is going up 1. Y'all see that? Okay, you can look at the X's, you know it tells you left and right. You can look at the Y's, you know it tells you up and down. So you already know what's going to happen. So fill out your table. Once you do your table, graph it out. And break. Go. I know you don't have to do that, but go ahead and fill that in for me, okay? Okay. What went with 1, 3? because you're going left 2, up 1. So you subtract 2, and then you go up 1. So this one's going to be negative 1, 8. What was this? Is it, it's 10, 10, 3? Sorry. And then where does it go to? 8, 4. And then this one is, and it goes to, all right. Okay, again, when you do yours on your own, if you choose to forego the table, that's fine. But for this one, we needed to show it just because they gave us the blanks. So negative 1, 4, negative 1, 8, 10, 4, no, 8, 4, sorry, 8, 4, and 8, 8. Questions about that? Whoa. Hopefully y'all are using a straight edge because mine looks a hot mess. All right, look with me. Oh, wait, rigid or non-rigid? It is rigid, okay? This is a rigid motion, okay? It does not change the shape. It does not change the size. Those things stay the same. It just slides the image. Anytime you slide the image, you're not actually changing the shape of it. Okay, number 10. Look at number 10. They want you to write a function for that. Remember that when you write a function, you are going to say x, y goes to something. You fill that something in. Where does x, y go to? What happens to your x's? That's right. So I just have x, comma. What happens to the y? Minus 12. It's all good. We don't have math bullies in this class, y'all. Don't be mean to each other. All right, we're going down 12. Then B says classify it as a rigid or non-rigid. What would you say? It is rigid because what are we doing? We're just sliding it down. So it is a rigid move. You are doing your homework on page 107. Everybody in this class only has to submit that one page because I physically saw you take your notes. Put your name on page 107 so that it's in the picture. Okay, I need your name in the picture. Do that. Either, well, not now because the bell's going to ring in like 1 minute. So do that for homework and turn it in. That's all you got. What? Yes, do that whole page 11, 12, 13, all of that. You literally have 3 problems, Josh. You got it. You're good. You're good. You're good. Okay, let me stop this so I can upload this video with sound.